This classroom activity, 11.0, not all the Math 2 teachers are going to do. I made the decision, let's say 2 days ago, when I was preparing lessons for this next unit. I think Unit 11 is going to be your hardest unit so far. I know that doesn't make it, when I say hardest unit, it's going to be really hard for anybody who doesn't know how to follow a set of procedures. There's going to be a list of things that you have to do, and some of you are actually going to like doing what we're going to do because it's something that makes things perfect. Let's just go with that, okay? And the best way, in my opinion, to actually see it is to do this activity called Algebra Tiles. We're going to use Algebra Tiles to attempt to make perfect squares, and it will be done as a class. I'm going to use this. In the old days, what I would do is I would go get a big bag of Algebra Tiles, and I would pass them out, and you guys would have them in your hands. Well, I don't have enough of those. Those were all given away about 10 years ago, so we don't have them anymore. But what I did find is I found a website that has Algebra Tiles. This is the website we're going to use. In this website, we can click on Algebra Tiles and we can create things. So on your worksheet, the worksheet you have in front of you, it says use Algebra Tiles to model expression x squared plus 6x plus 9 and draw it below. But you guys don't know what that means. So here's the website. On the left-hand side of that website, there is a bunch of choices, and I'm going to click on Algebra Tiles. And you were supposed to make something that said x squared. So what I do is I go find an x squared, and this is an algebra tile. I can make the algebra tiles bigger or smaller. I'll make them as big as I can make right there. That is x squared. On your paper it says you need to have an x squared plus what? 6. So this is 1x. The reason this is called x squared is because this side is x and this side is x. X times x is x squared. This is considered 1x because one side is x and the top is going to be considered 1 unit. How many of these x's do we need? We need how many? 6. So 1, 2, 3, and I need 6 more, or 3 more to make 6. These are algebra tiles. Literally, we used to, in the old days, have bags of these. And then how many do we need? We need plus what? 9 single units. Now, these are x's, but over here, there are single units as well. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. Now what I'm going to do is I'm going to rearrange them just a little bit. So before you go to draw these things on your paper, I'm going to just show you what this looks like. And I'm going to do something that maybe wouldn't come naturally to you. I'm going to double click this and turn it that way. Double click. Turn it that way. Double click. And what happens with x squared, 3x and 3x is 6x. What do you notice about this particular thing? It's very satisfying because it became a perfect square. That's the whole idea. So when you are over here on this worksheet, what you are trying to draw is you're trying to draw an x times x, which is x squared. We had a 1 times x, which is x. And this is really an ugly drawing, but that's okay. Another one, another one. Yeah, that song, I know. X, another x, and another x, 1x, 1x. So that makes the 6 x's. And then what did we do? We had the single 1 times 1's. And that's what we created with our algebra tiles. That's as big as I can make it for you. These are all a 1, a 1, a 1, a 1, a 1, a 1, a 1. now that you actually know what this is supposed to look like, it says, number 2, x squared plus 6x plus 9 is called a perfect square trinomial. Why do you think it's called a perfect square trinomial? I bet you can answer that question. Whatever you think the answer is, write it down on your piece of paper. Why do you think that is called a perfect square trinomial? It's a very easy answer. I'm going to put, it makes a perfect square. So now what I'm going to do is I'm going to go to number 3, which says create a partial square with algebra tiles to represent x squared plus 2x plus blank. So I go over here. I need to get rid of some of these things. Let's get that one away, that one away, that one away, that one away, that one away. So what this shows is this is x squared, this is 1x, and here's another x. X squared plus 2x. X squared plus 2x. This is what the drawing should be like for number 3a. X squared plus 2x. When you go over here, you're drawing an x squared plus 1x, and another x makes 2x. Draw it below. We just did that for part A. Now let's see if you can answer this question. How many unit tiles, meaning the little single small tiny squares, do you need to complete the square? Complete the expression above to show how many unit tiles it took to complete the square. You guys said 1. Then all you would have to do is plug in 1 for that picture. And then the big key to this whole thing, why are we doing it, is this next question, part C. What are the dimensions or factors? Dimensions or factors of the completed square. Remember, this was x times x to make x squared. X times 1 gave you x. X times 1 gave you this x, and 1 times 1 gives you 1. So when they ask for the dimensions, they're asking for, well, what's this? And what's this? Those are your dimensions, and you just put a little plus sign in between those two dimensions. X plus 1 times x plus 1. Write this in factored form as a square. X plus 1, we have how many of them? We have 2 of them. X plus 1 quantity squared, the quantity of x plus 1 squared. Part D. What we did is we took something like this, x squared plus 2x plus blank, and we completed the square. Why do you think the process we did is called completing the square? That's what we're going to do this whole unit. 3 of the sections, 3 of them, will be dealing with something called completing the square. You're going to learn how to do this algebraically. So instead of me talking about what we're going to do with algebra, I thought, hey, this is a great way for them to see what we are doing physically with algebra tiles. That's why we're doing it. That's why, and I think the other Math 2 teachers are a little bit afraid to do something with technology. So, hey, consider yourself special. Why do you think the process is called completing the square? Come up with an answer. Put what you think it is. But I'm going to put my answer, and then we'll see if you need to modify yours at all. This is called completing the square because it makes a perfect square that factors perfectly. It makes a perfect square that factors perfectly as well. In this example that we just did you notice that it was an x plus 1 and another x plus 1? If you were to go up here to this one, do you know that this top is x plus 3 times an x plus 3, which makes x plus 3 squared? Look at how this turns into a perfect binomial squared. That's what completing the square is. So then what they're going to do is they're going to say, okay, now take what you just did, but what if we went to 4x, and what if we went to 8x, and what if we went to 10x? What would this be? So let's do a couple of those. If I go to 4x, x squared plus 1x and 1x, I need an additional, that's 3x. I need to turn this one sideways. 1x, 2x, 3x, 4x. I think you might start getting the idea of what you would need to complete the square. If you know what this little piece has to be, then what you can start thinking of is what the dimensions are going to be. That's what this whole idea is trying to get you to realize. If you still need to draw it out, draw it out. But I think some of you now are starting to get the idea of what they're asking for. They're asking for what does that have to be and what will it factor to? How many tiles do you need? If it's plus 4x plus c, what's going to fit in that little corner piece? That's what they're asking for. You're going to say, this one needs 4 of those little ones. What would the perfect square trinomial be with the c value plugged in? This becomes x squared plus 4x plus 4. And then what they're asking for is, well, what will the dimensions be? X, and remember how this was 2 and this is 2? You would write it as x plus 2 quantity, the quantity of x plus 2 squared. You could make algebra tiles work for every single one of these things, but eventually you're going to start to see a pattern. The pattern's going to be the same for everything. Just curious. I want for you, second period, to say this out loud. Do you have an idea of how many tiles you're going to need to add for this to work? What do you think it's going to be? 9. If you said 9, you're correct. There's about at least 6 of you who know what we're doing at this point. That would make x squared plus 6x plus 9. Now I'm curious, do you know what's going to come into this perfect binomial squared? What's going to be here? If you said x plus 3, you are correct. You are understanding how to do something that a lot of kids don't understand how to do. When I say we're completing the square, that's what we're doing. Now, if I have the 8x, 1, 2, 3, 4, 1, 2, 3, 4, I'm hoping you know how many are going to be to fill in that spot. How many? If you said 16, you're correct. You have a 4 times 4. 16, x squared plus 8x plus 16. Figuring this thing out here and figuring this thing out here is going to make 11.1 so much easier, by the way. What does it factor to? X plus 4, not 4x, x plus 4 units on each side. If you need 10x, you kind of know that there's an x squared. There's going to be 5 of these boxes and 5 more boxes. And you're trying to figure out what's going to complete that square. How many of those little single units, if you know, say it out loud. Ooh, over half my class understands how to do it now. That's better than the other Math 2 teachers because we're doing this activity. I'm telling you. X squared plus 10x plus 25. Do you know what this is going to factor to? You are getting it if you said x plus 5 quantities, the quantity of x plus 5 squared. Good. Then they're going to ask you some deeper questions. The questions are deeper because it's not just, hey, you see a pattern, but can we generalize it? How does the number of tiles needed to complete the square relate to the coefficient of your linear term? How does this relate to this number? That's what they're asking. To this number, to this number, to this number. How do these numbers relate to these numbers? Are they the same? What did we do to go from, oh, if there were 8, I drew 4 and 4, and then we did something to get to this number. There's a way to go from this number to that number. Do you have a pattern yet?
Yeah.
What do you say? Go ahead, Ben.
Divide it by 2, and then once you have that number, multiply it by itself.
There's a way to say multiplied by itself. Anybody have a different way to say that, a mathematical term? Square it. You take this middle term, you divide it by 2, and you square it. There is a letter for this. I don't remember if you remember this or not. AX, whoa. This is ax squared plus bx plus c. We talked about that last unit. This is the b. You take that b value, you divide it by 2, and you multiply it by itself, is how Ben described it. Mathematically, that means you square it. That's what we're doing with these things. That's how we complete the square. And as a matter of fact, that's what this number 6 is asking. How could you do this in terms of b? Well, let's simplify it by saying we add b over 2 squared. And then they ask you, find the value of c that completes this square. If you know that your b value is 12, do you know what the c is going to be that's going to complete the square? You can either use this formula or you can use the pattern you used before because it's the same thing. What will it be? What's c going to be if you know? If you said 36, you are correct, but I'm going to show my work right here. You take the 12, you divide it by 2, and you square it. 12 divided by 2 is 6. 6 squared is 36. What happens if it's negative? Does that change anything? A negative divided by a positive is a negative, so that would be negative 3. But what happens when you multiply a negative 3 times a negative 3? What does it become? So the negative doesn't change the c value at all. It may change the factored value. That's different. We'll talk about that in just a little bit. And then x squared plus 3x. Uh-oh, this one doesn't come out nice and neat. So what does Mr. Paramo recommend? This is why we taught you fractions. If 3 and you divide it by 2, don't go to a decimal. Keep it as a fraction. Put 3 over 2. It doesn't reduce. And then you square it. Square the top and square the bottom. You know how to do 3 squared. You know how to do 2 squared. What is 3 squared over 2 squared? It would be. That is why we taught you fractions. So you can give us answers as fractions. It's easy. Don't make it harder than it is. One thing I do want to show you before I go to number 8. Remember how we had x squared minus 6x? If we were dealing with algebra tiles, and I were to pull out drawing another one. If I have x squared minus 6x, the only way to get these to be red or negative is to have this up here as a -1 and a -1 and a -1, which means x minus 3 at the top. That -3 makes a positive 9, but the only way to get these to be negative in the middle is to have in your parentheses a negative value. We'll come back to that in just a bit. Number 8 says, what's the relationship between the coefficient and the constant? How is B related to the C? Well, we already wrote this down. B squared, half of B squared, is equal to C. Which is basically the same answer for number 9. The only issue is they say when you factor it, what's it going to be? So D, how are we going to figure out D is? D is going to be half of B. This one's kind of harder to see because they're asking you to really go back to this chart. And they're saying, hey, what does this have to be when you know that the C value is this? When you did the half of B to figure out this number, well, what was the half of 10? It was the 5. The 5 is what goes in there. What's half of 8? Well, the 4 goes in there. The half of 6 was 3. When we're figuring this out, it's just half of B. We don't really have to square it. I did something. Let me figure out what I did. I think I moved that. Yep. I think it goes right there. Okay, that looks right. It says now, use this process to write each of the following expressions as perfect square binomials in factored form. So do you know what this factors to? It's a perfect square trinomial. Half of this squared is 49. What goes in parentheses squared? Do you know what goes into here? If you said plus 7, you are correct. But what about fractions? Those are so hard. No, they're not. I'm serious. Like some of you go, oh, fractions, they're so hard. They make this so much easier. What's half of 5? If it doesn't go in evenly, just say 5 over 2. Is that 5 over 2 times 5 over 2? Isn't that the same thing? So what goes in the parentheses? X plus. That's it. Don't make it harder than it is. Half of B. But what if there's a negative? What do you think the sign has to be of the parentheses? If you think you know what goes here, including its sign, say it out loud. I heard several correct answers. If you said -4, you are correct. This, when it's factored, is half of B, by the way, every time including its sign. So now what they do, the very last problems are basically, do you know how to do what we just did? So I'm going to do a couple with you, and then what I'm going to do is I'm going to give you some time to finish this worksheet. If you know what the b value is to complete the square, if this is 18x, what's going to go in for c? Half of b squared. What is half of b squared? Do you know? If there are 9 of those x's and 9 of those x's, they're asking you what is going to fill in, what's going to complete the square? Plus 81. Because half of 18 is 9, and you square that, that's that. But when we factor it, it's x plus, exactly. So I'm hoping that makes sense to you. I'm going to jump to 14 because it's an odd number. If you have a 7x and you're trying to figure out what half of it squared is, 7 over 2 squared, square the top, square the bottom. And then when you go over here, this is kind of what I do off to the side. And then when I go over here, I just go x plus 7 over 2, quantity squared. Makes it so much easier for me when I'm dealing with fractions than it is with decimals. I can do that stuff in my head. So should you. I'm going to stop the notes, but I think you should be able to do the rest of these on your own. I'm going to give you about 15 minutes.